What's going on, YouTube? I'm back again, and we are number 13, I believe. So now I got ahead of myself on this one, and I put the current solution I have. And as you can see, well, let's just go ahead and read the directions. So you're given an array of integers. On each move, you're allowed to increase one of its elements by 1. Find the minimum number of moves required to obtain a strictly increasing sequence from the input. So the example we have, 1, 1, 1, 1, is going to be 3. So basically what it's saying is, how do you get to the point where it's 1, 2, and 3? So this is how I went about it. And I don't think I read the question, or read it enough times to understand what it was really asking for. So what I ended up doing is looping through and then checking if the current element and then the one in front of it was the same, and if it was, then I would just add go up by 1 and then return it. And obviously the answer was right, but it was just too, I just figured I knew it wasn't really true, so I had to find another test case for this, and the test case for this should be 12, and obviously I'm not getting that. So let's go through the actual solution for it now. Let's go and loop through, so it'll be the same. So loop through. I don't know why I just erased everything, could just have that. So I is last, then array, no, array input array. Length, and then we'll do 1 plus plus. Okay, so we'll do the same thing. We'll compare. We'll say if input array at the current element is greater than or equal to input array at not the current element, but the element in front of it, then what we'll do is declare this variable, which will get the difference. So it'll be input array at the current element, and we'll add 1, and then we'll subtract it by input array. Oops. So that'll give us the difference. Then input array current element plus 1, and we'll set that equal to input array plus 1 at the current element. And what we'll do is, okay, so let me return now we're getting 12, and also we're getting 3. Now, I guess what I was trying to demonstrate is how I did my first solution, and the mistakes I did. I think what I was doing is just comparing those elements, and if they were the same, I would just add a count to it. So if these weren't, so we were getting 0 for this, and this was getting 3, so it was making sense of it. So I guess it was only going to work if I believe all the elements were equal. So now this actually gives you, I wish I had another test case for this, but this actually gives you 12 here, which is the way you go around this problem. And that's it, and we'll see everyone back on algorithm number 14.